Okay, so today is our second lecture for topic number 3. Okay, and our class on Monday. Okay, we already covered the first 4. Okay, which we explained the concept of central tendency, calculating the mean, median, and mode. Okay, so basically we have discussed the components. What are the advantages, disadvantages of each of the method. Okay, mean, which is one of the main drawback is it can be affected by small, extremely small or large value. Okay, there is only one value of mean, and then the way to calculate, we divide into two notation. One for population, which we use the symbol mu, and the other one for sample, we use the notation x bar. Okay, but the process to calculate for both is the same, summation x over n. Okay, and then we also determine how to calculate median, which is the value in the middle. Okay, so the advantage is not affected by extremely small or large value because we do not add or divide with anything. So basically, we just arrange the value from smallest to the largest, and we take the number in the middle. Okay, for even number series, so you need to take the two numbers in the middle and divide by 2. Okay, to get the median value. Okay, and then we also look at mode, the number with the highest frequency. So basically, when you plot your data on a histogram, so the number, the interval or the group that has the highest frequency represent the mode. And for mode, you can have more than one mode, okay, depending on your data. If there are 2 intervals or 2 groups that has the same number of frequency, then meaning your mode will be 2, okay, not only 1. Okay, so those 3 represent the measure of central tendency, okay, which is basically looking at how where your data is located in the middle of the observation. And then we also look at these 3 concepts of skewness, okay, zero skewness, positive, and also negative skewness. Okay, positive, the mean is on the right side of the tail. Okay, negative, the mean is on the left. Okay, positive is because your data is affected by extremely large value. Okay, and vice versa for negative skewness, the data is affected by extremely small value. So that's why the mean is pulled to the right for positive. Okay, but for negative, the mean is pulled to the left. Okay, so the median stays the same in the middle. So the only changes is between the placement of mode and mean. Okay, whereas for zero skewness, all 3 values are located in the same, in the middle or the same value. And I also mentioned that this is also known as the normal distribution. Okay, whereby it is the concept that will be looking at very closely, okay, in the next few in the upcoming topics. Okay, so today we're going to cover the second part of the chapter 3, okay, on the concept of dispersion. Okay, from the root word disperse. Okay, or in Malay we call it serakkan. Okay, so how dispersed is the data? Okay, bagaimana terseraknya the data? So when you have a series of observations, okay, besides knowing what is your mean or what is the number in the middle, what is the number with the highest frequency, okay, in statistics we also need to learn how dispersed is our data, meaning that, okay, you want to know whether most of the data is around what value, is located within what value. So let's say if okay, let's say in this semester's class, okay, BEEQ1023, okay, pengantar basic statistics. So let's say around 50 students, okay. So by the end of the semester, then I will know what is your marks, okay, what is your final grades. Okay, so let's say most of the students in this semester class, okay, gets around, everyone will have marks in the region of, let's say, 70 to 80%, for example. Okay, so meaning if most of the students' marks are around 70, let's say around 40 students, okay, 40 out of 50 students, the marks are located between 70 to 80 percent. Okay, and the remaining 10 students, some got A plus and maybe some got B minus and below that. Okay, so we can say that most of the data is located around this number because 40 students out of 50 students have marks around this range. So what we can say is that the data is not dispersed. Okay, dia tidak terserak lah. Okay, not dispersed because most of the marks are grouped around this area or this region only. Okay, but let's say if I change the example, so let's say 10 students in the class got marks, let's say around 60 to 65. Okay, and then another 10 students got marks around 66 to 75, for example. Okay, and then we can go on. Okay, another 10 students between 80 to 85. Okay, and then another maybe 10 students below 60, let's say around 50 marks, 50% to let's say 60%. So we can say that our data or the grades for this semester is very dispersed because the students are some students are around B plus, some students are around A minus, some students are around A group, A grade. So if this is the case, then we can say that our data is in terms of the grades, okay, is very dispersed. Okay, so that is what the idea of dispersion is all about. Okay, so you want to know whether your data is located around the same number, okay, or the same value, or scattered, okay, in many different intervals. Okay, so that is the idea of dispersion. Basically, you want to get to know your data better. Okay, so how dispersed or the spread of the data. Okay, so that is the idea of dispersion. And there are a few ways to calculate or to determine your dispersion value. Okay, the easiest one will be range. Okay, or in Malay we call it julat lah. Okay, so range or julat is basically you just take the highest number minus with the lowest number or the smallest number in the data set. Okay, so in this example, out of these 5 observations, okay, the highest is 80, the smallest is 20. So range is 60. Okay, so it is a very simple approach or simple method to calculate. Okay, you only take 2 numbers. So in a way, this simplicity in calculating the range only gives you just one number. Okay, but you do not know in terms of what is the number in the, I mean, whether your data, how many data is located within 20 to 40 or 50 to 60. Okay, because you only take largest minus the smallest. Okay, so that is also the limitation of range. Okay, it only involves 2 values. Okay, and then but the most common one, okay, is variance and standard deviation. Okay, so basically variance is the square of variance. Standard deviation is the square of variance. Is the square root of variance. Okay, so once you calculate standard deviation, when you take the square of standard deviation, you're going to get variance. So variance will always be bigger than standard deviation. Okay, so if you calculate variance first, you take the square root of variance, you will get standard deviation. Okay, or if you calculate standard deviation first, then you can calculate variance by taking the square. So because of that, variance will always be positive lah, because it is the square of standard deviation. Okay, standard deviation can be negative. Okay, but variance cannot, because variance is the square of standard deviation. Okay, so basically both the formula will be very similar. It's only that once you get standard deviation, you take the square to calculate variance. Okay, so what is variance and standard deviation? Okay, here it shows that standard deviation are non-negative. Okay, but you can also get negative number actually. Okay, but usually the standard deviation will be non-negative lah. Okay. And then for population whose value near the mean, the variance and standard deviation will be small. Okay, so if you look at these 2 points here, for population values near the mean, variance will be small. Okay, population which are dispersed from the mean, the variance and standard deviation will be large. Okay, so earlier, in last Monday, okay, when we learned about mean, median, and mode. Okay, so these 3 are the measure of central tendency. Okay, so when you look at the mean, basically you take the sum of all values divide by n, then you get one value. So basically mean is the number also located in the middle. Okay, it's the average. So what it means by this point here, okay, if the number is near the mean, the variance and standard deviation will be small. So if you go back to the example which I gave just now. So let's say in our class, okay, of the 50 students in our group, okay, of all the 50 students, the average marks, okay, let's say most of the students, from my previous example, the first one, okay, let's say 40 students got marks around 70 to 80, okay, for example. Okay, so 40 students out of 80 students, out of 50 students, okay, 40 students got marks between 70 to 80. So if we take the average of, if we take the mean of all students in this class of 50 students, okay, whereby we know that 40 students are, they got marks between 70 to 80. So by right, okay, if we take the mean of 50 students, we might get marks also around 70 to 80. Let's say we get marks around 72%, 72%. So that is the purata, the mean marks of all the students in this group. Okay, for example, so 72% is the mean. Okay, so because most of the students grade are around 70 to 80, and then another 10 students could be slightly below than 70, and some students could be more than 80. Okay, but most students are around this region. So when you calculate the mean, you also expect to get that the purata or the mean to be around this number also, because most of the students are around this range. So 72%, let's say the mean, okay, the mu is 72. Okay, so if this is the case, the mean is 72, and point number 2 here, for population whose values are near the mean, variance and standard deviation will be small. So if this is the mean, 72, and we know that most of the students, 40 students out of 50 students, the mark is around 70 to 80, which is near to the mean. The mean is 72. And also, most of the students' marks is quite near to the mean. So if this is the case, when you calculate the variance or standard deviation, it will be small because it's a measure of dispersion. In other words, our data is not dispersed. It is located around the same julat or the same range. Okay, so that's what it means. Once you get the mean and you look at the data, if the most of the data is very close to the every student from student number 1 to student number 50, okay, if most of the individual student mark is very close to the mean, so we can know that the mean and the variance, the standard deviation and the variance will be small, because it shows that the data, the grade is not dispersed. But if the mean is 72, okay, but when you look at the individual student grade, let's say there are students who get 40%, there are students who got 45%, there are students who got 50% in the final grade, there are students who got 55%. So when you look at the individual mark and you look at the mean is 72, but the individual mark is very far from 72. Some students are very far away from 72, which is the mean. So if this is the case, then we fall under the third point here. If the data is dispersed, it shows that the data will be far away from the mean, then the standard deviation will be large. Okay, so I hope you get this concept of dispersion. So basically, is how you spread your data. Let's say if you take if you take if you have let's say you take satu genggam let's say you go to the kitchen, okay, to your kitchen, and you take a handful of sugar, okay, satu genggam gula, okay, a handful of sugar, and you put, or you spread the sugar on the floor, for example, okay. So let's say you take the sugar, okay, garam lah, satu genggam garam or gula, okay, and you put on the table here. So if you spread the sugar all around the table, okay, meaning you cover the whole table with the salt or sugar, so meaning that you can say that the data, the standard deviation or the variance is very big, because you cover the whole table with the sugar or salt, okay. So this is what dispersion means. So if this is the case, when you calculate the variance and standard deviation, the value will be very big, okay. But if you spread the salt or the sugar very close to each other, meaning just at one place, okay, so meaning that that bunch of salt or sugar that you take from the container, okay, you only put the sugar or salt, okay, very close to it, meaning just at this one place, okay, not spread as this one. So in this if this is the case, then the variance will be small, okay, will be small. The variance will be big, okay. So that is the same idea here. So when you talk about variance and standard deviation, it measures the dispersion. If the data is located all over the place, okay, then the variance will be big, and vice versa lah. If the data is located around the same region, the same number, okay, which is very close to the mean, then the variance and standard deviation will be small. Okay, so that's how you actually get information from the variance and standard deviation. Okay, you need to compare with the mean. First, you calculate the mean first. Okay, once you know the mean, then you calculate the variance and standard deviation, and you compare the value from variance and standard deviation with the mean value, and you see how big is the value of the variance compared to the mean. Okay, so that is the reason why we calculate variance and standard deviation, okay, which is the measure of dispersion. Okay, so you want to know, so if somebody asks you once, let's say if somebody asks me at the end of the semester, okay, what is the, I mean, how do my student perform, okay, in BEQ 1023, okay, in this semester. So if that is the question, okay, so once I calculate the standard deviation, then I know whether my student perform, most of the students have similar quality or performance, okay, based on the variance of the grade. All the students are meaning there are some very good students, there are some very average students, or there are some very poor students. But if all of you are getting similar grade, then I can say that all students or most students perform perform the same way, meaning whether you are getting A or A minus or whatnot. Okay, so the formula to calculate variance and standard deviation. So the same with the concept of mean. Okay, we need to differentiate between population and sample. Okay, but in the calculation of mean and standard mean, the population mean and sample mean. Okay, if you recall from our lecture last Monday. Okay, for population mean and sample mean, this part is the same. Okay, only the symbol changes. From mu, we use x bar. Okay, but in terms of calculating the mean, it is still the same. Summation x divided by n. Of course, sample we use the small n. Population we use the capital N to distinguish between the data from sample small n or the data from population we use capital N. Okay, but in terms of getting the answer from the calculator or from the software is still the same process. Okay, but that is not the case for variance and standard deviation. The formula will change based on sorry. So I think let's keep this slide just now, right? Okay, so range largest minus smallest. Okay, so we have population variance and population standard deviation. Population variance and also sample variance. Okay, so for population variance, okay, first is the symbol, okay, or the notation. We use the symbol sigma square. Okay, so here we call it sigma. Okay, so sigma square is the notation or the symbol that we use to denote population variance. Without the square, it becomes standard deviation. Okay, so if you write sigma, it means population standard deviation. Okay, SD. Okay, but if you put sigma with the square here, it becomes population variance. Okay, so the notation sigma denotes population value. Okay, just like the mu for population mean. Okay, sigma denotes population for variance and standard deviation. Okay, you put sigma square, it represents variance. You remove the square, just sigma alone, it becomes population standard deviation. So the formula is summation of the total sum of each individual value minus with the mean. So in order to calculate variance or standard deviation, you need to get the mean value first, okay? Because that is the process of calculating. That's why point number 2 and point number 3 here, okay? In order to know whether your data is dispersed or not, you must compare against the mean, okay? So if the data is located around the mean, the variance will be small. If the data is located far away from the mean, then the variance and SD standard deviation will be large. Okay, so in order for you to compare, that's why you need to calculate the mean first. So you can see here, X minus mu is basically you are comparing the data with the mean. Okay, that's why it is the measure of dispersion, comparing the data from the mean value. So every value minus with the mean, and you take the square value, and each of this process you take you sum for every item and you divide by total number of observation. Okay, the square value represents variance. Okay, so here you have this simple formula here. Simple example. Okay, you have this monthly data of traffic citation, saman lah. Okay, how many citations or saman is dikeluarkan from at this particular place. Okay, so you have 12 observations, or N is equal to 12. Okay, January to December. Okay, so to calculate the mean, okay, because this is for a population data. Okay, so that's why we use the notation mu first for the mean. Okay, because this data belongs to the population. So summation X over N, you add everything, divide by the number of items, or 12 items, you get the mean, to the population mean to be 29. Okay, once you get the mean, then you can proceed with the calculation of variance. Okay, so as you can see from this example here, okay, so in terms of the process, okay, of course you'll be using the calculator, whether your Casio, Canon calculator, or the online calculator, which I gave you the link in your OL. Okay, but you need to know how the process is done first before you simply click on the button to get the data. I mean, to get the answer, because if you do not know this process, then you will not be able to interpret what it means by standard deviation being large, what it means by variance being large or small. So that's why when you understand the process, okay, then you can use whatever tool, whether online calculator, Microsoft Excel, okay, as long as you can appreciate and understand the process, okay, behind this formula. So again, okay, the formula is summation X. Okay, summation X divide summation of X minus mu square. So X is the each item in the observation minus with the mu. You take the square and you add every single observation with this with the difference, and divide by the number of observations. Okay, so here, okay, so this is every X value. Okay, so X minus mu is basically 19 minus the mean just now. So the mean from the previous example, from the previous slide, we know that the mean is 29. Okay, so 29 is the mean. So in the next step, 19 minus 29, you get minus 10. Okay, 17 minus 29, you get minus 12. 22 minus 29, you get negative 7. Okay, and then the rest follows. Okay, 10 minus 29, okay, you get negative 19. So x minus mu is 29, okay, from the previous slide. So you repeat the process and then you take the square, x minus mu square, and then this is the product of the square, and then summation, you sum everything. Okay, so this part, summation is this one, 1488. X minus mu square is this part, okay? So basically, this is the deviation from the mean. Every item you minus with the mean, so you want to know how far each of this item is from the mean value. Okay, so that is why we call variance and standard deviation the measure of spread from the mean. Okay, so you are comparing, you want to know how your data is spread when you compare with the mean value. Okay, whether your data is located around the same number. Okay, as what my example of the if you spread the salt, okay, on the table, whether you cover every corner in the table, or the salt or the sugar is located only around the same value. Okay, so you want to see whether you are in this case or something somewhat in this case. Okay, whether your data is very spread or not very dispersed. Okay, so the process that once you get this 1488 divided by 12, you get 124. So 124 is the variance. So by right, standard deviation is 124 square root. Okay, then you will get the standard deviation. Of course, it is not shown in this slide. Okay, but if you want to calculate the standard deviation, okay, standard deviation is the square of 124. Okay, so you can just press, if you use your calculator, okay, 124 square root, then you should be able to get the standard deviation for the population. Okay, because this example only shows you population variance, okay, which is the square. So by default, the formula is to calculate variance. So if you want to calculate standard deviation, you need to take the square root of the variance number. Okay, so that is one part. Okay, and then we proceed straight to the sample variance product. Okay, which is the same as the same concept. Okay, we want to measure how the deviation from the mean value. Okay, but the only change, okay, first is the symbol. Okay, you note that the symbol now become S square. Okay, compared to sigma square. Sigma square is the population variance. Okay, population variance. But sigma square is the sample variance. Okay, SP. Okay, so in terms of the formula, not just the symbol that changes, but also the formula. You notice that the denominator now is n minus 1 instead of just dividing by n. Okay, so if you look at the formula for population variance, okay, the numerator is the same, summation x over minus mu square. Okay, but this one divide by n. Of course, the capital N denotes population data. Okay, but we just divide by how many n, how many observations in the data. Okay, but for sample variance, you need to divide by n minus 1. So let's say there are 10 observations. So 10 minus 1 will be 9. Okay, in this example here, there are 12 observations. So if this is a sample data, not population, so let's say we assume this one is sample data. So this one will be n minus 1, which is divided by 11. Okay, so the only so the main change is the denominator value. Compare the variance will be dividing by n, but sample variance will be n minus 1. So it will be 1488 divided by 11. Okay, so of course, in terms of the value will be not much different. Okay, but if you were to answer this type of question in your exam, in your quizzes, I mean now because it is done through online quiz, so the answer will be if you use the formula to calculate. Let's say that the question asks you to calculate population variance, but you use the formula to calculate sample variance, meaning you choose 148 divided by n minus 1 instead of dividing by n. So your answer will of course be different. So you need to know whether the question is referring to sample or referring to population. If it is referring to population variance, dividing by n only. Okay, but if you're referring to population sample, the data belongs to a sample. Okay, so the denominator is divided by n minus 1. So this is the main beside the symbol lah. Okay, sigma square, s square compared to sigma square. Okay, but in terms of the calculation process, okay, of course in the online calculator, okay, you can choose you need to choose the right option lah in the calculator. Okay, so for example here you can see that in the calculator here, okay, you have the options whether to use population or sample. If the data refers to population data, so you choose population. If it is belong to sample, then you just choose sample and then click calculate. Okay, so this is just a matter of choosing the right option lah. Okay, the same thing if you're using your calculator. Your Casio or Canon calculator also have the similar option, whether you want to calculate sample variance or population variance. Okay, so you need to know which button or which option to choose in your calculator. Okay, so but for the online tool, it is clearly specified ialah population or sample. Okay, so the example given is very similar, but this one just a short example. Okay, there are 5 observations. Okay, 1, 2, 3, 4, 5. Okay, what is the sample variance? So basically, you repeat the same process. First, you need to calculate the mean. Okay, so the mean value, of course, is not shown here. Okay, because x bar or the mean value is the sum of all 12 plus 20 plus 16 plus 18 plus 19 divided by 5 lah. Then you will get the mean value. Okay, so if you look at here, 12 minus mean, you get negative 5. So by right, the mean will be what? Okay, what will be the mean value here? 17 lah kan? Okay, so 12 minus 17, you get negative 5. 20 minus 17, you get 3. So your x bar, okay, or the mean value here will be 17. Okay, which is you add everything and you divide by 5 lah. Okay, so that's how you get the x bar equal to 17. Of course, it is not shown here. Okay, so then you repeat the process similar to population variance, and then you take the square of the deviation, and then you sum everything, which is the part of the numerator formula here, summation of the deviation square, you get 40. Okay, so the main difference is n minus 1. So your n is 5. Okay, so if this data is a population data, so you only need to divide by 5. But because this is the word sample is mentioned here. Okay, the word sample is clearly mentioned. So when you see the word sample mentioned in the question, you need to refer to the sample formula. So 5 divided by 1, you get 4 lah. Okay, so then you get the variance, the sample variance to be 10. So if you want to know what is the sample standard deviation, it will be the square root of 10 lah, the square root of 10. Okay, which is not shown here lah. So you can calculate manually in your calculator. Or in your you can key in this data in your online calculator or your calculator yang biasa lah. Okay, so this is variance, sample variance. Okay, so to get sample standard deviation, just take the square root of 10. So that will be the solution for sample standard. Okay, so here is just what I mentioned just now. Okay, the example only gives you variance. So you take the square root, you will get the value for the standard deviation. Okay, so so that is basically how you calculate the variance, and also whether for population and also for population sample. Sample variance versus population variance. Okay, so once you calculate the variance, you just take the square root of that to get the standard deviation, okay, whether for sample or for population. Okay, so that is the two things lah. Okay, so here for example, how to interpret. Okay, okay, so here you have two examples. I mean, one simple example, one with a smaller standard deviation than the other one. One is 7.51 against 10.74. Okay, so we can say that in terms of the spread of the data. So we can say that the data for Georgia is less spread than the data for Texas, okay, because the standard deviation is smaller than Texas. Okay, so that is how you actually determine. Okay, so okay, so let me go back straight to the original, to the first slide. Okay, so here explain and apply the measure of dispersion. Okay, and then 3.6 is to calculate and explain the variance and standard deviation. Okay, and one more beside the variance and standard deviation, okay, there is also another method to calculate the measure of dispersion, which is another small item is what we call measure of position. Okay, not dispersion, but we want to know the location of your data. Basically, is similar to median. Median is also like a measure of position, because in median you arrange your data from smallest to largest, and you determine the number in the middle. Okay, so measure of position is basically is another way actually to describe your data, whether your data is spread, is very spread or not, by looking at this measure of position. Okay, in Malay, I think we call it quantile or quartile. Okay, you have the Q1, quartile 1, quartile 1, quartile 2, quartile 3. Okay, so in English we call it quantile. So I think it's quite similar term. I'm sure you learned this concept or these measures before. Okay, so another way to describe the spread of your data, besides using variance and standard deviation, is also we can use the percentile or the quantile. Okay, it can be referring to the same thing, quantile or percentile. So basically, this one, you are trying to locate where is your data, what is the 10% or the 25% data belongs to which value. Okay, usually the most popular one is Q1, okay, Q2, and Q3. Okay, what is Q1? Q1 is the 25th quantile. Quantile yang ke 1/4. Okay, the 25th quantile is what we usually call Q1. Q2 is the 50th quantile, or in other words, is also the median. The 50th data yang nilai yang ke 50%. Okay, the 50th value. Okay, Q3 is the 75th value. Data yang nilai dia is the 75% in the data. Okay, so these are the common one, Q1, Q2, and Q3. That is what usually we refer to. The most, of course, you can also calculate different percentages, 25%, 50th%, and also the 75th% data. Okay, so the 25th% is the Q1, 50th% is the Q2, which is also similar to median, because median is also the 50th%, the data in the middle. Okay, the third quantile or the Q3 is the 75th% value. Okay, so that is, and the formula is basically n plus 1 multiplied by p over 100. Okay, so what is p? P is basically the percentage that we are referring to. So let's say just now I'm interested to know what is Q1. So what is the data in Q1? Q1 just now is the 25th%, right? So then this P becomes 25. Okay, this 25. So I want to know what is the data located in the 25th% value. So so this P, LP will be the L25 lah. Okay, or the Q1 value. Okay, and then n plus 1, n is the number of observation. So basically what this formula does, okay, it does not give you straight the answer. It only gives you the location of the data. So you need to arrange your data again from smallest to largest, and referring to the number that you obtain here, then you need to decide, then you need to determine what is the value that is being referred to in the formula here. Okay, for example, okay, so you have this data here. Okay, 15 the amount of commission, okay, by these 15 brokers. Okay, so you want to calculate the median first and quantile. So basically median just now is the Q2 as I mentioned. Okay, Q2 is the 50th percent, okay, which is also similar to median. First quartile is the Q1, okay, Q1 or the 25th percent value. Okay, the third quantile just now is the Q3 or equal to the 75th value. So whenever you mention Q2, it is also the median or the 50th quantile. Okay, Q2 or the 50th quantile. Okay, the number in the middle is also called median lah. Okay, so when we talk about quartile, whether Q1, Q2, Q3, so Q2 is also the median, Q1 is the 25th, Q3 is the 75th value. So using this simple example here, so what you do is just arrange, okay, organize from lowest to the largest value. Of course, this can be done automatically in Excel. Okay, when you key in your data, you can highlight your data and just select what is the quantile. Okay, there is a command straight away to obtain this in your Excel. Okay, so but the manual process, of course, you need to understand how this is being done first before you can use your computer software to calculate this. Okay, 1460, and then this one is already being arranged from the smallest 1460, and then 1471, 1216 until the highest value is 2406. Okay, so when you want to calculate, let's say the 25th, the Q1 and the Q3. Okay, so basically when you plug in the value, okay, so recall that you have 50 numbers, 1, 2, 3, 4. Okay, so there are 15 number of observation, or n equals to 15. Okay, so that's why n is 15 here. So n plus 1 is 15 plus 1. So if you want to calculate the Q1 or the 25th percentile, so basically it's 25 over 100 multiplied by 16. So you get 4. Okay, the same thing here. You want to calculate the third quartile or the 75th percent value. So n plus 1 is 16 multiplied by 75 over 100. You get 12. So 4 and 12 is not the value. Not the answer that you can get. So the value that you plug in into the formula does not automatically gives you the answer. So you need to, when you arrange your data from lowest to highest, so what 4 is the fourth value, 12 is the 12th value. So then you can decide what is the fourth value, what is the 12th value. Okay, based on the sequence of how your data appears. Okay, so this is a very simple, straightforward solution. So, but things will get a bit complicated, okay, slightly complicated, if your percentile is not an exact number like this. 4 and 12 is an exact number. So fourth means, what is the fourth number? So you just look at your data when you arrange from smallest to highest. So 1, 2, 3, 4. So the fourth number from arranging from smallest to highest, the fourth will be 1721. That's how you get 1721 lah. So the 12th number in the observation will be, this will be the 12th number. Okay, 2205. So 2205 will be the third quartile. Okay, but when you plug in the formula, but you do not get an exact number like 4 and 12, you get something like 1.75, meaning that the number is in between 1 and 2. Okay, so you cannot say that the number is the number about the first observation. It is also not the second observation. It is between the first and the second observation. So this is what you need to do, what we call interpolating. Okay, you need to interpolate your data. So here is another example here. Okay, not based on the previous example. So here the book gives you 6 new observations already arranging from smallest to the highest, 43, 61 until 104. Okay, which is n equals to 6. Okay, so you want to calculate the 25th value. The same procedure applies. N plus 1, there are 6 observations. So 6 plus 1 multiplied by 25th over 100. So you get 1.75. So 1.75 means the number 1.75th value. So the first number is 43. The second number is 61. So you cannot use 61 or you cannot use 43 directly. but the number is between 43 and 61. So you must start with 43 first. Okay, because the number does not exceed 61. So it's just in between 43 and 61. So the formula is basically, okay, is the first number, okay, 43, plus the remaining 0.75 here, multiplied by the difference between 61 minus 43. Okay, and then you get the answer, which is you get the number to be 56.5 based on this simple formula here. Okay, so so that will be the case for any other number, as long as the number that you obtain is not an exact number. So you need to do a little bit of interpolation. Okay, so let's say if I change this one, let's say I change this one to okay. Now let's calculate what is the L75, meaning what is the third quartile. Okay, can you guys calculate now? Okay. Okay, I might simply ask anyone from the group, okay, from the attendance, from the list of attendance, okay, to show your answer. Okay, calculate what is the 75th percentile from this example also. What do you get? What is the 75th percentile? Afika Zaidi? Afika Zaidi, mana? Oh, you're not there, Afika Zaidi?
Yes, sir.
So what is the answer? Come on, it doesn't take 20 minutes to calculate something that can be done in less than 20 seconds. So I will take note all the names which I call, okay? So everyone will get a chance, will be called their name. So as long your name appear on the screen, okay, meaning that once you attend the class, and if I call your name, you don't respond, so it will be a minus point for you lah. Okay, just to make sure that you are all participating, not just simply attending the class and not doing anything. So that is what I don't like about this Webex session, okay, for a subject like this. When in a face-to-face lecture, at least I can show that you are doing your work, okay, but classes like this, Afika, mana jawapan? Where's your answer?
5.25. 5.25.
5.25 is not the answer. What is the value from the question?
Quartile
5.25
725.
5.25 is just the location of the number, not the final answer. I want the final answer.
Oh.
For example, in the example just now, the 25th percentile refers to 56.5. Okay? The 1.75 is just the location of the data. That is not the answer. It is just the part of the process.
Hmm.
Kamu yang nak mengira? Lambatnya lah you all. This thing can be done in not more than 1 minute saja. Once you get the answer to be 5.25, 5.25 is just the 5.25th value. So then based on the data, it's just 6 observation. So it will be the number between 5 and 6. Okay, the 5th and the 6th value. So 0.25, then you just interpolate as what the example is. I'm sure you learned this before. This is not something that you only learn in degree. Okay, you have learned this maybe in your secondary school already, this interpolation thing. Okay, so it's what? 101.75, okay? So make sure when I call up your name, okay, I think I don't call your name immediately after I give you the question. So I want everyone to be on your toe, meaning you are all doing your work, okay, not just simply switching on your laptop or your phone and then not paying attention. Okay, that's not how we learn or study, okay, for during classes, okay. So I want everyone to participate actively during our 1 hour short, 1 hour plus of lecture. Okay, so it will be what? 101, the 101, 101.75, okay, in the observation. So that will be the simple solution for this. Okay, so 5.25 is just the location of the data between the 5th and the 6th value, 5.25 value. So it will be between 101 and 104. So 0.25, you do the interpolation like this, so you should get 101.75, okay, as what some of your friends, only 2 of you in the chat actually sharing the answer. Okay, I'm not sure what are the rest are doing. Okay, so that's why I don't like this WebEx session for subject like this. Because I do not know whether you are doing or you are actually doing something on your table. Okay, not just simply listening. This subject that you cannot learn just by looking at the screen. Okay, you need to start doing something. Okay, so that is for the quantile. Okay, so I'll stop here. Okay, I'll continue the rest of the few slides on next Monday. Okay, so for the remaining 10 minutes or so, okay, so what I want to do is few questions from the book. Okay, so I will call, okay, again, I will jot down the name that I call at random. Okay, anyone. Okay, so the person which I call, okay, not necessarily I will not call the person again, okay, but usually, okay, I will expect to call few students in one class, okay, because chapter 3 onwards, it is no longer like chapter 1 or chapter 2 where you can just listen to me talking alone, okay. Chapter 3 onwards requires a lot of calculations because this subject is statistics. It's not pengantar sains sosial or kenegaraan Malaysia where it's just listening to your lecturer talking. Okay, so you need to do the calculation actively during class. Okay, so okay, so refer to the your textbook. Okay, let me We have a few minutes to go, around 15 minutes. Okay, so your textbook, it will be on page 84. Let me, 80, okay, so we start with question. Okay, so what I need you guys to do is use this one, the variance and standard deviation calculator tool that I give you. Okay, so using this simple online tool, okay, key in this data here. So this one is which one is the mean, median? Okay, we do the simple. Okay, question 59, this one. Okay, question 59. Okay, this one. Okay, so you have this data 32, 21, 60 until 41. Okay, the range is of course the highest minus the smallest. So that one I think okay, compute the standard deviation. So this one is clearly you can see that it is for sample. Okay, sample standard deviation. Okay, so I give you 2 minutes. Okay, then I will call anyone at random, and then you need to share your screen. I want to see. Basically, you're not even doing anything. Just key in this this one piece of data in the online, and then you choose sample and you calculate what is the standard deviation. Okay, I just want to know that you are all on your screen doing your work. Okay, not just simply watching on your phone. Okay. If you are for some reason you are using your phone, then snapshot your answer and then share on the WhatsApp group. Okay, so there's no excuse for you not be able to participate in the class. Okay, question 59. Question number B. Okay, calculate the sample standard deviation. Okay, it should be done already because what you are doing is just key in the data in the website and just press calculate. Okay, so we already used this website before. I'm sure you should know how to key in your data on the one column alone. Okay, Tan Boon Yu. Okay, share your screen.
Prof, I will snapshot.
Okay, tak kisah. Just what in your WhatsApp is it? In the WhatsApp group is it?
Yes, Prof, but I just finished for the A. I still need some time for the B.
No, I don't want A. I just want the B, the standard deviation, using the online tool I gave you, the website.
Oh, wait a moment, I need some time. Sorry, Prof.
Ayo, I already explained. Use the website I give you.
No, Prof, because my browser has some
so many
problem.
things to cover. That's why I even provided you with the link. so that you don't have to use your calculator. By right, if we were to learn face-to-face, you need to do this manually on your calculator. You're not going to bring your laptop during exam. Okay, but because the nature of our teaching this semester is based on online, so the only way I think we can do this is by using this online calculator. Okay, but that will not be the same, will not be the method if you were to learn this subject physically, face-to-face. Okay, so I think your life is much easier compared to your seniors that have to learn this subject using calculator. Okay, meaning you need to learn to punch the number on your calculator rather than just pressing the button on the website. So berapa? Sita Saladur, anak perempuan Saladur.
Yes, sir. Wait.
Yeah. Huh?
I'll share the screen.
Yeah, share the screen. When I call your name, I expect share your screen straight away, okay? Because I think 3 minutes just to key in few observations is more than enough already.
Okay. Can you see?
No, just a blank screen. Okay, so from next classes onwards, okay, this is how I'm going to test and make sure that you are learning, okay, actively in the class. Okay. Mana Sita? Where's your screen?
Saya tengah share screen, sir. But
Click the first one on the share, the top one, meaning you're going to share the whole screen of your desktop rather than only certain part of your browser.
can you see now?
Yeah. So what is the okay? So if you look at the formula, so berapa jawapan dia? 310.622. Okay. Variance standard deviation is 17. Okay. So if you look at the formula, there you can see that the n minus 1 in the formula. Okay. So meaning that if you click on the population, then you will get a different one, meaning the formula will not be dividing by n minus 1. Okay. So that's how you determine whether it is sample or variance. Of course, because the question already specified it is from sample. Okay, so you need to choose the correct option to get the number. Okay, so variance will always be bigger than standard deviation. Okay, because standard deviation is the square root of variance, so that's why the number will always be positive lah. Okay, 17.62. So there's nothing. It's not that you achieve a lot in terms of calculation because it's the computer that it's the software that does it for you. Okay, but as long as you know how to calculate, okay, using whatever tools, whether Excel or online calculator. So if I were to give you any assignment in the future, okay, to perform, to do any data that requires you to calculate variance or standard deviation, you can use this option, this website as well, okay, to calculate, to make sure that you choose the correct option lah between sample or variance. Okay, so of course, we can do more. Okay, I think that one we will cover on next Monday. We're going to finish on the remaining slides on the Chebyshev theorem and also the empirical rule. Okay, because that one also require a bit of calculation as well. Okay, and and also I will do also another few questions on variance and standard deviation. Okay, and also on the quantile. Okay, Sita, you can stop sharing. Okay, because if you look at the form in this calculator here, you also have this percentile calculator. Okay, whereby you can calculate whether you want to calculate the 50th percentile, or you want to calculate the 75th percentile, or you want to calculate the 25th percentile. Okay, that can also be done in the percentile calculator. So this is what we will do in the next class. Okay, so in the meantime, what you need to do is you can practice using the example from the slides, the one that you did just now, the 25th and also the 75th percentile that you get 101.75 just now. Okay, you can try using the same example, but plug in into the online calculator and see whether you get the same answer or not as the one that you provided in the class just now. Okay, so I'll see you inshallah next Monday. Okay, so you know how this this subject, the way the session will be conducted from today onwards. Okay, so I expect everyone to be alert. Okay, to participate actively, not just simply watching the YouTube watching the WebEx from the comfort of your bed. Okay, but actively involve. Okay, because every time I call up a name, okay, so I expect you guys to be able to produce the answer there and then. Okay, not baru nak buka laptop lah, baru nak buat soalan lah. Okay, because we have a very limited time. Okay, and I think the tools, the online tools that I provided to you is more than is good. I mean, lebih but is easy enough for you to perform this calculation rather than using your calculator or any manual calculation for that matter. Okay, so thank you. Okay, Assalamualaikum and good morning.